Okay, we're live.
Okay, you guys ready for 7?
Yes.
Yep.
Okay.
Yeah. Okay. So for part 2, suppose pair computing sold an average of 45 P phones per minute in 2011. Yes, that means they sold 23,652,000 P phones in 2011. With a standard deviation of 10, they looked at their P phone sales data and determined that they are normally distributed. So for the question 4, sample size 4 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of X?
It'd be normal.
Normal. Normal, agreed.
I'll do the next one. Samples of size n equals 40 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of X bar? Normal.
Normal. Okay. A sample size of n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed X is less than 40? I don't know what we need to do.
You have to get a z-score.
Yeah.
Yep, we gotta get a z-score on this one.
For sample size n equals 4.
Not on his though.
Well, he went and did it on that probability applet, because there's a probability applet that's different, and so you can type in the mean and the standard deviation and do above or below. So let me look at the numbers here and see, and I'll type them into that. So you have a 45 and standard deviation of 10. I think you did it in Excel.
Okay.
Let me get there, because I did it there. Okay, so the standard deviation is 10, right?
Yeah.
And the sample size is 4. So the standard deviation 4. So the standard deviation of the sample means it's going to be 5. And then what's the mean is, what's the mean?
45.
Where's that paper? Sample size. Oh, n equals, where are we at? N equals 4. And, and that the observed is less than 40. What is the probability of the observed X?
So,
so let's just do 40 minus 45, right?
Yeah.
Over 10 divided by the square root of 4, right? Correct?
Yeah.
So that's -5 divided by 5, which is -1.
Yes.
Is your, so -1 is your
Z.
Z-score. So now you can take it to that other app and do -1. And it says that it's less than that or greater than that. It's less than 40.
Yep.
We can do 0.1587 blah 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 blah.
So it's 0.159.
Yeah.
And then for 7, a sample size of 4 is taken from the normally distributed 2011 sales data. What is the probability of, or that the observed X is greater than 35 and less than 55?
Did you guys download that other Z table that he had?
I haven't. I can find it. You get it pulled up.
It's davidmlane.com hyperstat davidmlane.com/hyperstat/z_table.html.
There we go.
Let me get mine pulled up here. Okay. Yeah, that'll make things go a little bit quicker.
Mm-hmm.
Hold up.
Well, notice that it's also 2 deviations away, so it's going to be 95%.
Yes.
But between 35, 55, oh, I got 68%.
Yeah. Away from
Oh, that's right, because it's only 1 deviation away, because the standard deviation is 10. So it's 68%. 0.683.
Okay.
Is that what you guys got?
Yeah.
Yes. So, yeah. Okay. 8 sessions.
Okay. What are you doing? Okay, under P. A sample size n equals 25 is taken from the normal distribution of 2011 sales data. What is the probability that n is greater than 41 and less than 49?
Sorry, my computer keeps get weird.
49. Now see, in that table, that Z table, it doesn't give us a place to put a different a number in there, a number of people with a so you get a different Z-score. The higher that the sample gets, you get a lower Z-score. So I don't know how to I don't remember how he said to calculate that. I watched the video on this, but I didn't work with it. I just watched the video.
That's where I was. I don't think, though, looking at going back and forth between the answers, he's not really looking for an exact number. He just wants a balance.
Okay, so if we type in between, what was it, 41 and 49?
41 and 49.
Yeah.
Recalculate. Is it 0.3108? Is that the answer he got? Is that the answer he puts up?
He puts up the probabilities about 95.
0.95.
Yeah, and we're not getting that.
However, he also has that exact answer for almost all of them. So I think he messed up on his.
Maybe he just copied
I
it.
think he copied and pasted a couple times.
Maybe.
Because he has the same answer for quite a few of them. I think he might have copied and pasted it wrong.
C equals
Try it by hand.
and the probability is about 0.16 using the 68, 95, 99, 7 rule or the 1587 exact.
That one's kind of strange.
I think it was a misstep type. But I think the answer is...
Well, there's still, the 95% rule is that they will be 2 standard deviations away, correct?
Yeah.
Right.
So I don't see how, because the sample size got larger. Now you have a, that's why. So we've got to just do the math.
We want to have to solve each individually. Instead of plugging the 41 and the 49, just calculate for the 41 and then also calculate for the 49.
45 sigma equals 10. Okay, I made this table in Excel. Let me see what happens when I type this in. So sigma is 10. My sample is 25. That means my standard deviation is 2.
Yes.
So then you take that. So then you take that to the calculator, to the applet table, and type in a z-score of 2.
Mm-hmm.
And And they're saying it's 95%, but I get 97%, 99%.
But even then, it isn't about on the.
That's for, no, I got the 25. So, yes, I got 95%.
Okay.
So it's just depending on what app you use.
Yeah. Depending on how you formulate it.
So with the sample size of being 25, that's the one I did.
Yeah.
I got a z-score of 2. And the
Yeah.
probability being 95%.
Yep.
That's right.
Okay, now I didn't do the n equals 4. So I can do the n equals 4. Now for some reason I get a z-score of 5 for that one. Why is that? Is the 45, standard deviation is 10, and sample size is 4. So that would be 10 divided by square root of 4 equals 5. Oh, that's why. Less than 35. 35 minus 45. Oh, I didn't do the I didn't figure out the z-score on it. That's a problem. 35, and this is 45. Okay, the z-score is -2 on that one. So on number On number 7, the sample size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed x-bar is greater than 35 and less than 55? We did that one on the
Yeah,
we did that one on that z table.
Yeah.
Correct?
Yeah.
Yes.
Okay, so number 7, number 8, the sample size n equals 25 is taken from the normally distributed 2011 sales data. What is the probability that x bar is greater than 41 and less than 49? So you can do the you need to get the z-scores for each of those.
Yep.
41 minus 45 divided by 10 divided by the square root of 25, correct?
Yep.
Yeah, that's right.
So minus 5, 10 divided by 5 is 2. No, it's only 4, -4. So it's a -2, correct? For
Yeah.
41?
Yep.
No.
When it's 49, it's going to be a 2 as well.
Positive.
Positive 2, though.
Is it a 2 on the other side?
Yes.
Yep.
Okay, so we can go to either applet then.
If you do that other applet.
And it's 95.45, right?
Yes.
Okay.
Okay. Are we good to move on to 9 then?
Yes.
Yep.
Okay. So I'm just going to read it this way. The sample size is 55. What is the probability that the observed X is greater than 50? That would find the Z-score again.
Mhm.
That would be 4. That would be 50 minus 45 is 5. And 5 divided by 2 is 2.5. Right?
Yes, that's right.
Yeah. I got 2.5 for my Z-score.
Yes. And we wanted greater than that, right?
Yep.
Mhm.
So that the probability greater than 50.
0.006.
Yes.
Yep.
Is that what he has for his answer too? Keaton?
Yes, it is.
Cool. We did it right.
I'm sorry, I didn't hear. Is it 0.0062?
Yep.
Okay.
Right. So then we're moving on to some new data that's from 2010. So I'll read it for you. Pair computing sold an average of 44 p-phones per minute in 2010. The standard deviation is 12, and they looked at their p-phone sales data to determine that the distribution is right skewed.
Now, if the sample mean, I have here, if the sample mean X bar is not normally distributed, you cannot compute probability. So we can, but that doesn't have anything to do with number 10, sorry. It has something to do with number 13 when we get to there. Sorry.
Yeah, that's actually the exact answer for 13.
Okay. So let's stick with number 10, right? What's the question?
The sample size 4 are taken from a right skew of 2010. Phone sales data. I don't like those phones. Is one of the shape of what is the distribution of net? Would be right skew.
Yes.
Yep.
Yep.
Because it gives it to us.
Yeah, it says it right there in the information. Right, so 11. The sample size 40 are taken from the right skew 2010 p-phone sales data. What is the shape of the distribution of X? So if it's above 30, where this rule comes in. So that's roughly about normal, isn't it?
Yes.
Yeah.
Is there a what is the zero?
The central limit.
Central limit.
Yeah, that same thing.
Baylene's already answered for us.
You can say it again, or I can read what it says if that helps.
Well, I just have wrote down if the sample mean, which is X bar, is not normally distributed, you cannot compute probability.
No.
Yep. The answer says no, the distribution is not normal. The normal probability applet is ooh, sorry, is only for normal distribution.
That's right.
So 14 and 15 is what we were doing on the questions above. With the different information, we get the sample size. 36 is taken from the right skew. In 2010, phone sales data. What is the probability that the observed X is greater than 36.5?
So finding the z-score again.
I got 0.9599. Well, everybody else got?
I haven't got to the normal probability yet.
1.75.
Yeah, that was my z-score, was negative 1.75.
Yeah, me too.
0.9599. Is that what you said, Allie?
Yep.
Right.
Yes.
It's greater. Yes.
Comes your favorite time next, Haley, whenever you're ready. So for this one, again, we have to find the, oh, sorry, for 15, are we ready to move on to 15?
Yes.
Yep.
Okay, so for 15, the sample size is 36, and it wants to know what is the probability of the observed data between 37.5 and 42.5. We gotta find the z-score for each of those again.
I'll do 42 if you guys want to do 37.
Okay.
That way we can
Okay.
speed up a wee bit.
Well, I'll do the 37 too, and then 2 are doing each of them.
Yep.
Oops, I got my camera.
Camera does that a lot of ways.
So the z-score is 1.25.
And it's negative 1.25 for the other one.
For the 35,
Oh, okay.
37.5. Yep, that's what I got. I wonder if for these ones, it's each time it's a negative and a positive. That's what the other two were. Well,
And the probability is 0.1056.
yeah.
Where did you get that?
That's for the 42.5?
The z-score was negative 1.25 and 1.25,
Yep.
and you shaded the area in
Yes.
between the two.
Mm-hmm.
I have 0.7887.
Yes.
Yep.
That's what I have.
Okay.
Yeah, that's the probability of between the two. Okay, I'll stop the broadcast.